Hello friends, today we are going to discuss resolution of vectors, and after that point we will discuss some problems related with the vector analysis. In the last lecture we had seen the law of parallelogram. The procedure for resolution is the same as law of parallelogram. So let us see. First of all, let us see what do you mean by the resolution of the vector. Suppose if you have given a vector like this, say v, that v is equal to, that v can be resolved into three components. That means you can resolve the v such like that v1 v1x plus v2y plus vz v3z. So here we then sum of all these three v vector sum of all these three v1 is v1 v2 v3 are equal to v. That means you resolve this component v or the vector v into these three types. That means you separate its x component, its y components, its z components. Okay, so that method is called as resolution of vector. So let us see here, a vector can be written as the sum of two or more vectors. Now that vectors are depending upon the components. How many components you require to describe the vector, how many directions you required, and that's why you can resolve such vectors into those components, sum of those components. So here you have given a vector v and it is resolved into three components, v1 alpha cap, v1 beta cap here. v1 alpha cap, v1 beta cap, or v2 beta cap, and v3 gamma cap. Where alpha, beta, and gamma are called as the unit vectors. Those vectors are unit vectors. Unit means it has one magnitude is equal to 1. So that cap is remain here. So alpha cap, beta cap, and gamma cap are the unit vectors. So alpha cap is the unit vector along the v1 direction, alpha beta cap along v2 direction, and gamma cap is along v3 directions. Now the process of splitting, so this is actual definition of the resolution. The process of splitting the given vector into its component is called as the resolution of the vector. So you can separate this vector into different sum of the different vectors, right? So the component can be found, and now if you want to find out the component, then you have to do some trigonometry. You have to use some trigonometrical equations and some mathematics. So let us see. The components can be found along the directions at any required angle, but if these components are found along the direction which is mutually perpendicular angle, then they are called as rectangular component. Now this is interesting one. Rectangular or the rectangle means what is the characteristic of the rectangle? All the opposite sides of the rectangle are parallel, and every side made made the angle of 90 degree, right? So the angle between two sides is 90 degree. Now in law of parallelogram we had found out some direction uh, of the resultant, but the parallelogram is in the parallelogram all sides are parallel, but the angle between two sides are not equal to 90 degree. Always when it will be equal to 90 degree, then it will be rectangle or square. So this is the special case related with the parallelogram. But when the angle between two sides will be 90 degree, then the components, means they are mutually perpendicular, the components are called rectangular components. So the figure shows you, the figure will show you the components. So see here O is the origin, and you have given that OA is a one of vectors, OB is one of vectors, and all other sides of the vectors, say BC and CA, all are made angle of 90 degree. Okay, so we have to find out their components. Now first of all we have to find the magnitude for this resultant. So OC is the resultant, or OC is it is diagonal, and according to law of parallelogram it is the resultant, that OC will be resultant. So consider vector r is equal to OC, which is originating from the rectangular coordinate system. Then we drop the perpendicular from point C to OA at point A. Then OA is equal to, you have known O is equal to Rx, OB is equal to Ry, being the component of OC, vector OC along x and y axis respectively. Then the law of parallelogram of vectors, according to this you can write vector R is equal to vector Rx plus Ry. You can write same this term in the terms of this equation in the terms of unit vector, as I cap is the vector along x axis and j cap is the vector along unit vector along y axis. Then you can write vector r is equal to Rx I cap plus Ry j cap. Now if the theta is the angle between the resultant made by resultant with the x axis, then one can find out the value of Rx and Ry using trigonometrical equations. So you can find it. See Rx is the adjacent term to angle. So you can you will use the equation for cos theta, then you can find out cos theta is equal to Rx upon R. R is the hypotenuse. So formula for cos theta is uh, adjacent side of the angle divided by hypotenuse. So Rx is equal to R cos theta. Then sin theta, if you take the equation of sin theta, then you may get Ry. Then you may get Ry, you may get the value for Ry, that is R sin theta. Okay. Now if you square the both equations Rx and Ry, so if you take Rx square and Ry square, then you may write this as R square cos square theta plus R square sin square theta, and by taking R square common you get the equation R square is equal to Rx square plus Ry square. And so the resultant R is nothing but the square root of Rx square plus Ry square. And one can find out the magnitude. So this is the magnitude of vector R for rectangular component. And if you want to find out the direction of R, then you will take the ratio for tan theta, that is Ry by Rx, and theta is equal to tan inverse of Rx plus Ry. Now if you have three components, then you can take vector R is equal to root magnitude of vector R is equal to root of Rx square plus Ry square plus Rz square. If two vectors are equal, it means that their corresponding components also equal, or vice versa. So if Ax I cap plus Ay is A cap plus Az k cap is equal to Bx I cap plus By is A cap plus Bz k cap, then Ax is equal to Bx, both will be same, then Ax is equal to Bx, Ay is equal to By, and Az is equal to Bz. So let's see one example related with this. You may get the idea about the resolution. You have given that vector A is equal to I cap plus 2j cap, and vector B is equal to 2I cap plus j cap. What are the magnitudes of the two vectors? Are these two vectors are equal? That we have to discuss. First of all, now here we have given two vectors. First of all, you have to compare these two vectors, these two equations, or this two vector with the general formula. Now what is general formula? The general formula is R is vector R is equal to root of Rx square plus Ry square. As you have given two vectors, so that you can write vector Rx square plus vector Ry square. And your actual equation is vector A is so A is equal to here. Now Rx is the term or the multiplicand of I cap. Or the Rx is the vector along I cap. So here you can write 1 square. So component of I cap is 1 and j cap is 2. So you can write vector A is equal to root of 1 square plus 2 square. 1 plus 4 is equal to root 5. Okay. Then you have given the next vector B is equal to 2I cap plus j cap. You can See the magnitude, you can, same formula is here. So the magnitude will be same. Now just difference is that the component of x component is 2 and y component is 1. Okay, so both have same magnitude. The magnitude vector a and vector b are equal. But the next question they have asked, that are these two vectors are equal? And recently we had seen that vectors are equal when the corresponding components are equal. Corresponding components are equal. That is, check once again here. If you compare axi cap, ayj cap and azk cap with bxi cap and byj cap and bzk cap, and they are equal, then ax and bx are same, ay and by are same, az and bz and same. So you have to compare these components such like that. So check, you have given I cap plus 2j cap and 2I cap plus j cap. Now the x component of both, if the vector will be same or equal, then both having same x component and same y component. But if you check in vector A, the x component is 1 and y component is 2. So no need to go further. Y component is 2 and x component is 1, so that the vectors are not equal. Though their magnitude will be same, vectors are not equal. Okay, now let us deal with some problems related with vector analysis. Our first problem is a, a vector makes an angle of 20 degree. A vector makes an angle of 20 degree and vector B makes an angle 110 degree with a x-axis. The magnitudes of these vectors are 3 meter and 4 meter respectively. 3 meters and 4 meters respectively. Find the resultant. So you have given that there are two different vectors. One is making an angle with x is 20 degree and another is making an angle of 110 degree. That means the situation is likewise that. So this is the x-axis and first vector is making an angle with a x-axis of 20 degree. So here is of 20 degree angle. And another vector is making an angle of 110 degree with x-axis. Okay, so here is your with x-axis. So here is the situation is likewise that. Here is that is your vector B and this is your vector A. Now if you want to find out, and you have to find out the resultant of A and B. If you want to find out the resultant of A and B, then you need to know the angle between A and B, and that angle will be why? Because 110 is the angle of between x and this point B, and 20 degree is the angle between x and point A, x axis and point A. So if you subtract both, you may get angle 90 degree. Then you have given that the magnitude of these vectors, vector A. So if you write OB, then OB has 3 meter length, and OA has 3 meter length and OB has 4 meter length. Okay. Then, so according to the law of parallelogram, you have the resultant formula for resultant, that is R is equal to A square plus B square plus 2AB cos theta. So A has magnitude 3, so R is equal to root 3 square plus 4 square plus 2AB means 2 into 3 into 4 into cos 90, that is 0. That's why this whole term is useless. Only this term is coming, has some value. So our new equation is R is equal to root 3 square plus 4 square, that is equal to 3 means 9, square of 3 is 9 and 4 square is 16, that is equal to root 25, and its square root is 5. So resultant has 5 meter length. 3, 4, 5 is the, so 5 is the resultant. Now the angle beta between A and R, then beta is equal to tan inverse of, so the formula is alpha is equal to q sin theta, or alpha or beta, you can take any notation. So tan alpha or tan beta is equal to q sin theta upon p plus q cos theta. So q has value 4, or A has value 4, sin 90 that is 1, P 3, Q 4, cos 90 0. So beta is equal to tan inverse of all this term. Okay, so beta is equal to tan inverse of 4 by 3, and after using log table you can find out that the beta is equal to 53 degree. Okay, so the resultant vector is in the direction of x and previous 20 degree that you have to add it here. Then you may find out the angle between the vector, resultant vector, and x axis is 53 degree, because the vector A is at 20 degree Celsius, 20 degree, right? So that 20 is, you must have to add it here. Must have to add here. Next problem. A spy reported about the suspected car. Reads as follow. The car moved 2 kilometers towards east made a perpendicular left turn, ran for 500 meter, made a perpendicular right turn, ran 4 kilometer and stopped. Find the displacement of the car. First of all, you have to convert the distances, all distances into meter. Okay, so 2 kilometer, 2 kilometers. So we can choose uh, the system in 2 kilometer. So 2 kilometer, 500 meter, that is equal to zero point 0.5 kilometer, and 4 kilometer. Now observe the figure here. Observe the figure here. Vector AD is equal to 2I plus 0.5J plus 4K. Okay, so 2I, that means it goes 2 kilometer first of all towards east, then take turn. That means it has completed the rectangle. Okay, uh, so you can describe vector AD. AD is the resultant, so that will be equal to 2I cap plus 5J cap plus 4K cap, x component. Now you can use Pythagoras theorem to find out the value of AD. AD is equal to, that AD is nothing but AE square plus DE square. AE square plus DE square. Now you can, substituting all this value, square root of AE square plus DE square, substituting appropriate value, you may get the answer. It is equal to 4 kilometer for 6.2 kilometer, as AE is equal to 6. So AD is equal to 6.2 kilometer. Then you can find tan theta, that gives you the direction. Tan theta is equal to DE, opposite side, upon adjacent side, that is equal to 1 upon 12. So tan inverse of 1 upon 12 is the displacement. The displacement of the car along, now this is the angle, and the displacement of the car is 6.2 kilometer. That is positive, along positive x-axis. Now the third problem is, find out the angle between vector A and B, where you have given the component of vector A. You have given that component of vector A minus 4, 3, 0 and 2, 0, 0. Now here we have to use a special characteristic for cross product. Okay, so you want to find out the angle between A and B. You can use this formula. Sin theta is equal to A cross B upon modulus of A dot modulus of B. So it's dot product of cross upon dot product. So theta will be equal to sin inverse of this term. Now first of all you have to find out the cross product. As cross product is, find out the cross product, and cross product is nothing but that is equal to the determinants, right? So determinant, so I cap, j cap, k cap upon x component is 4, y component is 2. So minus 4, 2, then 3, 0 and 0, 0. So after finding determinants, you may get A cross B is equal to minus 6k. And the modulus of A is equal to, then you can find out modulus of A. A is nothing but, according to the rectangular components, A is equal to square root of 16. 16 means square root of minus 4 square plus 3 square plus 0. So it is equal to 16 plus 9, that is 5. 25 is equal to 5. And vector B is equal to root 4, that is equal to 2. Now A cross B is equal to 6. Modulus of A cross B is equal to 6. And then you may find that mod A and mod B is equal to, or the magnitude of A is 5 and magnitude of B is equal to 2. So 5 into 2, that is 10, and 6 upon 10, tan inverse of 3 by 5, that is equal to 36 by 0.87 degrees. So this is the angle between this. You can find out the dot product simply. This will be homework for you. You can find it. Find out the dot product of two vectors A and B as 4 I cap plus 2 j cap plus 1 k cap, and B is equal to 5 I cap plus 4 j cap plus k cap. So A dot B is equal to A1 A2 plus B1 B2 plus C1 C2. Why? Because only the like terms can multiply. So I cap dot I cap is equal to 1, j cap dot j cap is equal to 1, and k cap dot k cap is equal to. Remaining all terms are equal to 0. So 5 into 4, 2 into 4, and 1 into 4. This is the characteristic of dot product. This is the characteristic for dot product. Let us see one more equation. Two forces 3 Newton and 4 Newton are acting at a point such that the angle between them is 60 degrees. Find the resultant force. So this is based on law of parallelogram. See, the magnitude of vector r is nothing but root of a square plus b square plus angle between these two. Now here you have given that p is equal to 3 and q is 4. Okay, and your formula is r is equal to p square plus q square plus 2pq cos theta. Now use here, p is 3, so 3 square root of 3 square plus q 4 square plus 2 into 3 into 4, that is 12 cos theta. So it is 9 plus 16 plus 12. Cos 60 is equal to cos 16 is equal to 1 by 2. So the answer is root 37, that is equal to 6.08 Newton. Now the direction is nothing but tan is equal to q upon q sin theta upon p plus q cos theta. That is 3 sin 60 plus 4 plus 3 cos 60, that is 0.4. So q is equal to tan inverse of 4.4 3 for 7 2, that is 25.3 degree. Okay, so you can find out these values by the formula, by using log table. Okay, so thank you.